Good afternoon, class. My name is Lucas Cleve, and this is my presentation on disc clutches. So to start off, what is a clutch? Well, a clutch can be engaged or disengaged to permit a smooth and gradual connection or disconnection between two members. Clutches are often used in manual transmission automotive vehicles and are placed between the engine and the transmission to provide a disconnect. In operation, the flywheel is bolted to the crankshaft, which rotates with the engine. The flywheel and the pressure plate have friction surfaces, which are typically steel. The clutch disc has a layer of friction material, commonly made of ceramic composites, and is squished between the flywheel and the pressure plate. This causes the clutch to rotate, sending power through the input shaft to the transmission. To disengage the clutch, the release fork pushes the throwout bearing onto the pressure plate's diaphragm springs. This causes the pressure plate to move slightly away from the clutch, releasing it to rotate freely with the transmission. Here is a short video to better understand the operation of a clutch. Multiple disc clutches have just that, more than one clutch disc. Clutches can be designed to operate wet or dry. Typically, dry clutches will be found in manual transmission vehicles and will have only one clutch disc. Wet clutches are immersed in lubricant and will typically run smoother, cooler, and have a longer lifespan. Having multiple clutch discs means they can have a lower diameter and still meet the required torque rating for a specific application. Most multi-disc clutch systems operate wet and are used in automatic vehicles. Note that multiple disc clutches are separate from dual clutch transmissions, which use two clutches that can be engaged and disengaged separately. We have some equations that can be used to calculate and analyze various factors of a clutch. But first we have to assume uniform distribution of interface pressure, and that we're working with a new or unworn clutch. These factors relate to the total torque that can be developed, the force acting on an area, the number of friction interfaces, and the inner and outer radius of the friction surface. These equations can be used when working with a worn clutch, but we have to assume uniform rate of wear at interface. Note that the assumption of uniform wear will give a lower calculated clutch capacity than when assuming uniform pressure. This table can be used to determine the coefficient of friction, maximum pressure, and maximum temperature of various materials. Well, that is the end of my presentation. I hope you learned something about disc clutches.